It was the 24th of February, 2023. It felt like an ordinary day. Little did I know that on that day I was about to start a project that would change the course of my life. Minecraft, as we all know, is a game of endless possibilities. A place where creativity has no limits and where you can shape your world block by block. For me, it all started when I discovered redstone. Redstone was this mysterious and magical material that could make things move, light up, or even compute. I was fascinated. I spent hours experimenting with redstone, occasionally watching some tutorials, trying to understand how it worked. And that fascination turned into ambition. I wanted to make my own redstone machine, something that felt truly unique. My first attempt, a small project. It was a 7x7 pixel screen, nothing fancy, but it had a controller that allowed a single pixel to move across the screen. It wasn't much, but for me it felt like a breakthrough. The moment I moved that pixel, I knew I wanted more. So on February 24th, 2023, I decided to start something bigger. Something I thought might just be impossible. And that's how this project, my redstone computer, was born. In this video, I'll answer 3 key questions. What can it do? How does it work? And how does it compare to computers in real life? Also, if you don't understand how this computer works by the end of the video, you actually don't have to subscribe. But if you do, you at least have to leave a like and then you choose if you want to subscribe or not. Let's first look what the computer can do. Well, everything on this computer is controlled using the keyboard in front of the screen. It includes every letter you can find on a standard keyboard, along with a spacebar, period, exclamation mark, question mark, 2 brackets, and even a delete and backspace key. The 2 brackets I rarely use, so it's actually much more fun to replace them with a smiley, for example. But we'll get back to that later. On the left side of the keyboard, there are 3 options to select on which row to type on the keyboard. These are labeled R1, R2 and R3, which stands for row 1, 2 and 3. Each row is 9 characters wide, with row 1 being the top one and row 3 being the bottom one. The delete key removes every character in the selected row. So for example, if we type this, then select the second row and press delete, it will clear the entire second row. The backspace key works a bit differently. If you accidentally press the wrong button while typing and only realized it after you pressed the button, then you can press the backspace, and when backspace is activated, you can then press a different key that will replace the old key. And you can do all of that without affecting the rest of the row. In summary, we're able to type text and a few specific characters onto the selected row, and even correct mistakes as needed. But here's the thing, we quickly have to talk about the third question. How does it compare to computers in real life? Because even though this is all neat and it's fun to show to friends, to a more experienced person, this is clearly not an actual computer. This is much simpler, since we're actually just sliding letters from the right side to the left side on the screen, and there is no actual control to activate specific pixels. There's also no way to run specific programs, which means this isn't actually a computer, it's more of a text typing system. I don't know. Now that we established that this isn't a real computer, let's look at how me from a few years ago made it work. So I think the best place to start is with the screen. The screen is arguably one of the most important parts of the whole thing. Here we have one screen module, and I'm really happy with how this turned out. Basically, we have 5 bits for the input, and depending on the combination of bits, a different torch tower gets turned on, and then the corresponding plate next to the torch tower sends a signal along these horizontal redstone lines, which connects directly to the screen for a 5x5 pixel output. So the letters or drawings you see on the screen is actually just stored in redstone torches in one out of these 32 plates. It might have been a bombshell of information, so just in case, let's look at a few basic examples of how it would work. In the first plate, we're gonna have a row of redstone torches, then 3 rows of torches only at the start and end, and then one last row of redstone torches. Then, when we select this plate, this torch arrow activates and makes these torches turn on and activate the redstone lines again. Then, the signal will go straight to the screen, and then you see we made a square on the screen. If we now want something else, like the letter M for example, we just draw an M with these redstone torches, like we did with the square. This time we select the second plate because that's where the M is stored, and then the redstone lines will activate, showing the letter M on the screen. This way we can quickly switch from the square to the letter M and also back just by changing a few bits. One thing to note is that with 5 bits you can have 32 different combinations, so that means we can have 32 pictures. And for me that was perfect, since I could have every letter of the alphabet plus a few extra random things. But that doesn't mean it's the max. Theoretically you can have as many bits as you want, until the delay is too high or it becomes too laggy or something. So now we just copy the modules and we need to make to move the letters. So let's first take 3 lines as an example. Basically, if we put a repeater, we can have another repeater lock that repeater, and that means it stores whatever it had originally. If the input is false and we lock the repeater and then try to change the input, nothing happens. But if we first powered the repeater and then locked it, we can turn it off again. So basically this repeater is storing the value, either off or on. With 3 lines it looks like this. Let's say we power the first 2 and then lock it. If we now do something else, it will anyways keep the original input. And then if we unlock and lock it again, it will change to the new one. Now we have 2 of them. If we first do 1, 1, 0 and then lock the first one, now we can change it to something like 0, 1, 1. Then lock the second one and then we can stop sending. Now we start 2 different combinations. If we want to slide everything to the right, we can first unpower the farthest one, then the one after, and everything is moved to the right. And then you can just do that again, and now everything is moved to the right again. Now just upscale with 5 lines, and then add a few more of those segments, and then you have the same thing I have here. So now that we know that we have a 5-bit combination that slides along these lines, which is the memory, and that the binary combination gets put into the screen module, which shows a letter or symbol on screen, the next step to understand is how the keyboard works. Because we somehow need to send a 5-bit combination depending on the button that we pressed, and then send one more signal to slide the coming signals into the memory. Hi, I'm standing next to a tree. Let's find out how the keyboard works. Well, this might be a bit much, so let's first do a simple example. Let's first start with 3 lines, because compared to 5 lines, 3 lines is easier to understand. Let's also add the buttons. We can do 3 buttons for now. Now we'll just do A, B and C, and it will make it easier to see, and a color. Now we need to wait for the button to give a specific output. Make the first one 1, 0, 0, the second one 0, 1, 1, and the third one 1, 1, 1. It's not like these are needed, it's just for an example. The easiest way is to just connect them above the original wires. And then you might think to just place the redstone torches for which one it should be. But this is actually the opposite, because if we now activate it, it disactivates, and if we don't activate it, it does activate. So if you have multiple combinations, they'll just all be on. Basically, if we just invert the signal, with off being on and on being off, we always make sure the redstone torches are off until we press a specific button, which makes the output go through. So just like we wanted, the buttons now connect to the correct lamps. And yes, this is actually pretty similar to how the screen worked, but like the opposite of it. You might notice the actual keyboard is made out of multiple layers, but that's just because the keys are so cramped together. The keys just go to their own layer, and then we just combine the layers. So it's basically the same, it's just a bit bigger. And when we do press a key, we also detect the signal over here, which makes some more lines activate, which makes the signal coming in go in the memory. And then we got our beautiful letter on screen. On screen. I did kinda skip over one small part, and that's the part where we choose which layer we type on. But basically, the output of the selection just goes through some wires, and then comes to this part. And when the keyboard signal comes in, we just lock 2 out of the 3 options. We just move some blocks up by pistons, which will make the signal go through. But if the pistons aren't held up, then the signal won't. And so we only need to power 1 out of the 3 rows of pistons to choose 1 out of the 3 rows we want to type on. But this is not the full story. When I built this device, I was incredibly happy, but there's always one thing I never finished about it. Ignoring some bugs. You might have already noticed it throughout the video, but this unfinished thing was supposed to be used for a storage system. And that's also why there were so many extra wires on the left that go all the way to the back into this thing. It was basically like the memory on the right, but then bigger and stacked. And there was way more of it. You would have had many save slots and you would be able to save, load or clear them. It would have been really cool if you can save sentences. In fact, almost as cool as you are. I wish I was cool. What's less cool is that I spent 4 weeks editing this video, almost 5, and YouTube doesn't even pay me yet. I'm even starting a Discord server that you can enter via the link in the description. I'll be pretty active in there, and I think it will be really fun to interact with fans. But if I can say one thing to any viewer, it wouldn't be to like or subscribe. It would be to rewatch the video, please. There were so many things like zooming in to get to the next clip, and way more edits. But you can also just right click and then press on loop and then just let the video play through. Or on mobile use the settings. And like always, please remember you're only allowed to subscribe if you want to see more videos.